All right, hello everyone. My name is Zyler Neese. Uh, I'll be covering InfluxDB along with Nico, Sam, and Bao. I'll be covering why uh, you should use it or learn it, as well as some basic concepts and general use cases. A little later on, Nico will be telling you about how to set it up and install it. And then Sam's going to be talking a little bit about the pros and cons of InfluxDB, as well as comparing it to other databases. And then lastly, we'll have Bao going over some examples and showing it live in action, which would be cool to see. So to start us off, what is InfluxDB? What it is it's an open source time series database, which means that open source means you have open access to the original source code to view and edit how you feel free, and it's used free of charge. It was created by Influx Data and written in many of the popular languages such as JavaScript, Python, Go, etc. Which is a really cool thing because you might think you don't know how to code in InfluxDB, but the fact that if you know how to do any of those languages makes it very easy to do. And then InfluxDB is it focuses on time series data such as operations monitoring, application metrics, sensor data, and real-time analytics. Why you should learn it? Well, in general, time series databases are the fastest growing segment in the database industry. So they're growing much faster than any other type of database. And on top of that, DB Engines is an independent website that ranks all the different databases. And InfluxDB is rated as the #1 time series database by a very wide margin, as you can see from the screenshot. It has a score of 28.52. And in second place is KDB Plus with only a score of 8. So that's over 3 times the score. Just really showing how far above and beyond InfluxDB is when it comes to time series databases. All right, so for some basic concepts, which anyone should know if they're going to be using it, if you're using InfluxDB, you're going to have a column which stores timestamps. Because you need InfluxDB is a time series database, so you need to have a time or a date or a time. So there's always going to be that column. There are also fields, which are made up of field keys and field values. Field keys are always strings, while field values can also be strings, but they can also be floats, integers, booleans. And then if you have a collection of a field key and field value, the pair together make up what's called a field set. So when I refer to that later, you'll know it's a field key and field value combined. And then there's also tags, which is similar to fields, but not the same, as tag keys and tag values only store strings and record metadata. So unlike in tag values, unlike in field values, it can only be a string. So it can't be a float, integer, boolean. And then a tag set is all the different combinations of all the tag key value pairs. And tags are indexed, which is why you should use them in certain situations, because the queries on tags are going to go faster. And one more term on this page to cover is a measurement. And what it is it's basically a table in SQL. It acts as a container for tags, fields, and the timestamps column. So if you ever see a measurement when you're using InfluxDB, just think of that as a table, which you guys all know. And then InfluxDB also has this cool thing called a retention policy, which has 2 different parts. First, it describes how long InfluxDB keeps its data, which can have a lot of good use cases, such as if you want to get the mean of a set of data over the past hour, you get the mean of the past hour, then you delete the data from the past hour and just keep the mean, and you can just repeat this. So it's awesome that it can just keep track of how long it's going to keep it before clearing it. And then it also tracks how many copies of the data is stored in the cluster. Next, a series. As you can see from the, well, a series first is a collection of points that share a measurement, tag set, and field key. So in the screenshot, series 1, census would be the measurement or the table. Location equals 1. And scientist equals Langstroth would be the tag set. So one's a tag key, one's a tag field. And then butterflies would be the field key. And then a point represents a single data record that has 4 components: the measurement, tag set, field set, and a timestamp. So it's pretty much everything you see in a series, except it also has to include a timestamp. And then each point is uniquely identified by both their series and timestamp. So use cases, when would you use InfluxDB? You'd mainly want to use it if you have time series with large volumes, but with any time series, it's a good choice, but especially with large volumes that has many data points, because if you're using a non-time series database, it's not nearly as scalable with a high amount of data points, time data points, which makes InfluxDB the database that you're going to be wanting to use in this situation. Some examples would be server metrics, applications performance monitoring. So if you have a lot of applications monitoring, you want to make sure that they're running smoothly and keeping track of the time. Network data, sensor data is huge, especially with COVID-19. Everyone was using sensors. Hold on. Okay, got it back. Sorry about that. Yeah, during COVID, everyone was using sensors, so it's essential that your sensors are getting, the data is being read properly and stored in the database properly. And then if you're into the stock market, you can have a large volume of data points over time, and InfluxDB is the perfect way to store and analyze all that data. And then other than time series with large volumes, if you're wanting to save data with the expiration date, like I was talking about before, they offer the retention policies that will indicate how long the data will persist. So like I was saying, if you want your data to delete every hour, every couple hours, every day, and just get something from that data before it deletes, retention policy is a really cool way that you can do that. And then I'm going to pass it on over to Nico to talk about installation and setup. Thank you.
All right, what up, guys? Today I'm going to be going over installation for InfluxDB, specifically on macOS and a few different Linux distributions. So right off the bat, macOS, definitely the easiest to install. All we have to do are these 2 commands: brew update and brew install InfluxDB. So this is dependent on the fact that you have Homebrew installed on your computer. If you do not, I highly recommend installing that, as it makes installations super easy. As you can see, it's only 2 commands, and our other Linux installations are much more difficult. So if you haven't already, go check out Homebrew and download and install their software. It's a great package manager, keeps everything up to date and makes downloads super easy. So moving on, we're going to go over the Linux installations for different, for Ubuntu, Debian, and CentOS. As you can see, each one is a little different. Ubuntu and Debian both use wget to retrieve InfluxDB from their website, and then similars kind of end there. The source commands are a little different in their file paths. And then CentOS is almost completely different. It uses yum to get it done, but you can just copy and paste this. The CentOS one might be helpful to you because we have downloaded CentOS for our other labs. So yeah, here are the commands for each operating system to get the installation started, mainly downloaded. So from there, Ubuntu and Debian use sudo apt-get update and sudo apt-get install InfluxDB. CentOS is a little different. We're going to use sudo yum install InfluxDB and sudo system control start InfluxDB. We're going to be starting that InfluxDB daemon manually. And then after we've done these on any operating system, we want to sudo system control enable InfluxDB to get that whole thing up and running. And then we actually have to allow our firewall in order for inbound traffic to pass to us. For Ubuntu, it's sudo ufw allow port 8086. And then CentOS, we're actually going to use a firewall command and manually add the port 8086, reload, and then list all. Again, this is crucial. Otherwise, you'll never be able to receive any inbound traffic from servers. And moving away from the installation, after you've completed those commands, you should be good to go and to start up your InfluxDB. Going to be going over some syntax. So InfluxDB syntax is very similar to MySQL. So starting off with the select statement, the select statement queries data from a particular measurement or measurements. Once again, same as MySQL. You can even see the star right here. Select star returns all fields and tags, exactly the same as what we're used to doing with MySQL in our class and in our labs. So some things you can do with select. You can select a field key, returns a specific field. You can select multiple field keys, and it returns more than one field. All you have to do is separate it with a comma. And then you can also select field keys and tag keys, and it can return specific fields or tags, whatever you want. And it's just important when you're selecting more than one thing, you include a comma to separate that. And it's important to note that pretty much the same as MySQL, if not exactly the same. And moving on to from, just like the select clause, the from clause, same as MySQL. The from clause supports several formats for specifying a measurement or measurements. So from measurement name returns data from a single measurement, and you can also return data from multiple measurements, once again separated by a comma. And this just basically gives you some data that your select clause can select from. And finally, the where clause. The where clause supports conditional expressions on fields, tags, and timestamps. If you remember from MySQL, the where clause acts as a conditional statement where you can weed out some data so your select and from clause can function properly. Right here in the second bullet point, you can see a kind of complete InfluxDB statement. So you're doing a select clause, then a from clause, and then a where clause, and then you can see a conditional expression right here. The where clause supports comparisons against string, Boolean, float, and integer field values. And then the supported operators include equal to, not equal to, less than equal to, greater than equal to, greater than, and also less than.
Okay, so I'm going to be going over some limitations of InfluxDB along with some pros, and I'm going to be comparing it with some noSQL and SQL technologies. Starting off here, I read some forums about InfluxDB and some user complaints, and one of the big ones was that the delete function can be a little bit buggy and difficult to execute sometimes. People found that they would delete something, go back, and find that it actually was not deleted. That can be troublesome. That can be a little difficult sometimes to work with. Another thing is the GUI based admin mode. People are a little picky and would like that to run smoother, which is understandable. And also a big thing was that in order to do some massive writes, massive queries on big data sets, you need to upgrade to the enterprise version, the paid version of InfluxDB. If you need more than 750,000 field writes a second, if you need more than 100 moderate queries per second, or if your series cardinality is greater than 10 million, that's just the size of the data that you're trying to work with. And also, most do not recommend InfluxDB for non-time based data. If you're just doing regular queries on some regular data sets, people probably wouldn't recommend Influx as their first choice. Going over to some pros of InfluxDB here. Starting off, it's an open source software, so people love to be able to see documentation and be able to that helps them solve some problems that they may find, fix some bugs that they may find as well, and know exactly what's going on in the system. InfluxDB is very scalable, which is very useful with time series data, and is very efficient and very helpful in doing big analysis. It's great for time series data analysis. This includes real-time data analysis, which is a great thing. You can have real-time values be input into databases and have functions run on them. And those functions are time-centric, which are important for this time series data analysis. And it's very, very quick and very useful. There's also no dependencies for setup. You don't need a special computer. You don't need RAM, or you don't need special RAM or anything like that. You just download it and you can get using it. It has a native HTTP API, which a lot of people like to use. And there's the free open source version available. That's great. People love to be able to not have to pay in order to use these softwares. So you can just download it, use it, and get right to working with it. Also, the language that it uses is very similar to SQL. It's easy. That makes it easy to learn, makes it easy to query. And so people can just hop right in, download the free version, and get to learning InfluxDB very easily. It also has very fast queries. This is what I'll be getting to next, showing some comparisons with some other noSQL technologies and SQL technologies as well. So starting off here, I found this website and they did tons of tests against other databases on some different tests, and these were the findings here. So InfluxDB versus MongoDB has a 2.4 times greater write throughput. Influx uses 20 times less disk space than MongoDB on those same tests, and InfluxDB outperformed Mongo by 5.7 times on its query speed, which is very significant there. MongoDB is a very popular noSQL technology, so that is interesting to see there. We also compared here with Elasticsearch. It had 3.8 times greater write throughput, 9 times less disk space, and 7.7 times faster response time for queries. That's also very significant and very interesting there to find. We have two other noSQL technologies here that we compared with. The first one here is Cassandra. This one is interesting, especially on the query speed. 4 times faster write throughput, 2.1 times less disk storage, and 45 times faster query performance. That is extremely massive difference right there for InfluxDB. It's very quick against these other noSQL technologies, And that's very good to see for our users. InfluxDB versus another time series database. So this is a good way to compare how other time series databases match up with this time series database in Influx. It has 5 times faster write throughput, 16.5 less disk storage, and 3.5 to 4 times faster query performance. So that shows that InfluxDB, in terms of time series analysis data, is one of the best out there in order to do that. So moving over here, this is just a little picture here showing the comparison of the outputs of different tables in SQL here on the left and Influx on the right. You can see there, the most notable here is the time. You can see how difficult it can't even really read the time there on the SQL side. It's lots of numbers, very confusing. But on the right here in Influx, you can see how the time is perfectly laid out. You can see exactly what you need in terms of the timings and everything. It makes it very easy to read. So here, doing some comparison against PostgreSQL, which is a big, very popular SQL technology. They did all these results were done on a cold cache. So just a cold cache, run these tests, which one's faster or which one performs better. And these were the findings here. So Influx used 1/4 of the space that Postgre needed, which is a very big deal. Does not use a lot of space and also is quick. So PostgreSQL here on 5 million rows of data, it took 3.694 seconds to query those 5 million rows. And on those same 5 million rows, it took InfluxDB 26.2 seconds, which is a little bit longer, which is actually significantly longer, which is interesting there. They shortened the data set here. They took a subset of that same 5 million rows and did on 500,000 records. It took Postgre 512 milliseconds to do that, 27 milliseconds on average, one single record. InfluxDB query, it took about 2,604 milliseconds, and finding about same average time on one single record. These were all run on cold cache, and these are just the findings here. So it is very interesting to see the comparison of Influx to these big SQL technologies that have a lot more progress and a lot more things done with them. So thank you for that. Moving on here.
Okay, so let's jump into some basic statements that we can use in InfluxDB. Most of the statements in InfluxDB will be similar to MySQL statement that we learned so far. So as you can see here, we have reace database, use database name to set the database for all the future requests. We can insert some data to the InfluxDB by using the insert statement, show measurements, select statement, from, where statement, drop statement if you want to delete some measurement. I think I will jump into the terminal to show you more detail about what we can do in that. All right, so after the installation has been finished, we can type the influx. So that will connect you right to the shell. Now we are in the InfluxDB, and I go over the database command. So the first one I want to show you is show databases. So we show you all the database we have in the InfluxDB now. And the one you have right now, just the default one, is called an internal and nothing else. So now if I want to use the database when connected to it, I just go use my DB and it shows using database my DB. So now I am connected to my database. The next thing I am interested in is my measurements. So by the default, it should be no measurements yet. So I can confirm it by using show measurements. So there are no measurement. To create a measurement, we use insert statement instead of create tables like in MySQL. So to do that, we use insert. So we can give it a name for measurements. So I put CPU and host equal not 1, value equal 10. All right, so then now we can show measurements, and you can see it's contain a measurement of CPU now. So now we have the measurement created. Now let's use select star from CPU to see everything that contain on it. And we can see the node 1 has the value of 10 and it's what time where the data were inserted. And also, as I mentioned before, the InfluxDB is a time series, so they always have the time field for all the measurement that you inserted. So now we have all the data. So if we want to remove it, we can do drop measurement and CPU. Oh, something's wrong. So drop measurement CPU. So then we can check show measurements. So there is no CPUs anymore. So we already create some measurement and then we drop some measurement also. So let's go ahead and recreate some measurement and insert more value on the measurement. So I insert CPU host equal not 1, value equal 10. I also insert CPU host equal not 2, and the value is equal 20. I insert CPU host equal not 3, and the value is 30. So then now we can go to select all of them. So then now we can go to select so then we can go to select star from CPU. So as you can see, there's all the values they have contained in the measurement. There's another way that we can see it. So we can use show series. So we have 3 value hosts, not 1, not 2, and not 3. We can also set the condition that we want to select from the select statement. So we do select star from CPU where host equal not 2. There we go. Now, another thing you want to do when you select the data from the time series database is select it based on the time range. So as we can do is select from CPU, we can do where the time greater than or equal now minus 5 minutes. So it's gonna return everything happened in the 5 minutes. So what if I change to 1 minute? So let's see, select from CPU where time now nothing happened, right? Because like we already create the measurement in the last 5 minutes. So in the last 1 minute, we didn't do anything. All right, so I hope it's helpful for you to make it through. My goal is just showing you the basic command that we can use in the InfluxDB. Thank you.